can't say it just took, I mean, yeah, you can say it took this long to get there, but it took us a couple of years just to get the paperwork in order.
Think about this. RWE is now teaming up with the Russians, right?
We start now. Okay. Welcome everybody to a meeting of the Montara Water Sanitary District. We're going to look at the tank and do a tour of the tank site. It's on its way. I'm going to let Clemens introduce people. Give the board members here, 4 of the board members. Clemens?
All right, well, thank you very much all for coming. Thanks for watching, if there should be anybody. Yeah, I think this is first of all, this is a wonderful opportunity that we would like to take to show everyone the current status of our tank project, which is actually the biggest infrastructure project that was ever undertaken in Montara or Moss Beach. So this is a $3 million project. We are building a 500,000 gallon tank here, and the purpose of this meeting is really a technical walkthrough. So we are going to hand this eventually over to SRT. Tanya is with SRT. Tim Monahan is going to do most of the explaining. We have here Dwight Wilson, Jim Harvey, Bill Huber, and Catherine Slater-Carter. That's 4 of the current board members. Scott Boyd wasn't able to make it. We also have 2 former board members here. We have Lou Wall and we have Bob Batasik. So I think this is something that's been in the works for a very long time. This was the first initial thoughts about this were essentially manifested in 2003 when the district purchased the water side. And since then we've done many things to increase the reliability of the system. We've done many things to increase our emergency preparedness over the years. Initial steps were mainline replacements, PRV station maintenance, essentially making sure that water can be transported efficiently, especially for firefall purposes from A to B, that it's available throughout the system, hydrant replacement projects, many other infrastructure projects. We already built 2 new tanks in this system. We replaced an old existing tank. At the schoolhouse site, we added also a 100,000 gallon tank at the schoolhouse site. So together with this tank, we will essentially within a year see 600,000 gallons of increased capacity in the system. That is quite a bit. It's going to increase fire flow and also regular storage for our regular demands. We will be able to run our wells much more efficiently, see energy savings. We're going to see prioritizing of good quality water over water that has to be treated to brought to the same quality. So we're going to see tremendous increases in cost savings there. I want to take the opportunity to give every board member an opportunity to speak, but let's keep it somewhat short so that we can really focus on the technical side. We really want to show off the project and get into the details. So if any one of you wants to add what I said so far.
I'd like to add that we have another honored guest here, J.B. Cockrell from the Coastside Fire Protection District, who came up. He's been interested in fire protection in Montara and Moss Beach for a lot of years, and it's a pleasure to have the fire district represented here as well. Thank you.
Anyone else? All right, then I would say we hand it over to SRT. Tim, do you want to just dive in and start explaining? Tanya, do you want to say something?
Well, I just think of thank you for having us here, and we're honored to be your engineer. Really,
what is amazing about this community, and I'm so honored to stand by these people who are your elected officials, and they selected just the right people to run the district, your manager, and they're so caring about the community, and they're doing the best projects at the best cost possible. I work for a lot of other agencies, and believe me, this is no small feat what they have done and continue doing, and I'm sure you will see it tonight in the rate study when you see how well the district is doing financially. So thank you for having us.
Thank you. Well, thanks, Clemens. Again, some of you folks were at the last board meeting. I made a presentation about the construction of this project that had just recently gotten underway. And now we're at a significant milestone right now. We've completed the excavation that you see here. And I don't have enough copies for the entire team, but if folks double up, this is a illustration of what this tank will look like, a cross section through the tank when it's finished. And this will help you get a sense of what we're building. The wall you see below us is simply a retaining structure. This is to retain the walls while we build this tank out of concrete.
Thank you.
You know what this is? So, as you see on the first page, we have
these walls going to be? I don't see any measurements there.
how tall?
Yeah.
They're going to be, it's 20 feet, these are going to be about 28 feet tall.
Wow.
Yes.
Thank you.
Now, to build this tank, it's a special design of tank. It's not just a reinforced concrete tank. It's a pre-stress and post-tension tank with a domed roof. It's an advanced structure. It's very complicated seismic rods inside and cables. And then after the tank is completed and cast, it's wrapped very tightly with post-tension wire and put into tension, and then we bury it. But to do that, we needed to open up the area to get down to build the tank, to get the workers in there. There was a number of ways we could have done it. We could have opened up a very large hole and banked the slopes on either side, but instead the contractor opted to build a tank, build walls straight down to eliminate some of the over excavation that he'd have to do and the material that would have to come back in to backfill it. The process is called soil nail wall, and basically what you see down here, we'll go down in a minute, we can get a better look at it. The contractor started the excavation from the top down, drilled anchors into the walls, put rebar on the wall and mesh, and then sprayed it with sprayable concrete or gunite, or we call it shotcrete in the business. And then once that first layer was stabilized, he excavated down another 4 or 5 feet, put in anchors, and the process continued until we're down at where we are right now, which is about 26 feet below grade. At this point, we're getting ready to put in the underdrains and piping that go below the tank, and a membrane will be put down, an impervious membrane for water, and then the tank constructor will come out here in about 2 weeks and begin forming the first slab, the base slab of the tank, then the walls, then the dome, and post-tensioning. So maybe at this time, if anybody has any questions, I can answer those, or we could walk down the ramp and take a look around.
How deep are the soil nails?
I knew that question was going to come. The soil nails at the top are longer, the longest ones. Those are about 16 feet long. And then there's 12 foot. The next two layers are 12 foot, and then the bottom one is 10 foot. 10 foot long, 10 foot deep. They're 1 inch diameter, and they're grouted into place with a special technique that allows them not to come out. And they've tensioned these to several 100,000 pounds each to try to pull them out, and they don't resist. They're very strong.
So those will actually help to keep the integrity of the tank when it's finished too, from any soil that might move in.
There is an added benefit in the end that this retaining wall, which will remain in place
will aid in strengthening our tank.
Right, right.
Yes.
In earthquake country, that's useful.
Yes, very useful.
So did I hear you say you're gonna build the tank in there? They're not dropping in a tank by helicopter or anything?
No, 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 no. It would be much too big. This is a 500,000 gallon tank. Very heavy, very impractical. It'll be built piecemeal down on the bottom. What they'll do first is cast the slab, and then the walls will be formed in place.
Concrete
And
also?
reinforced concrete.
Okay.
And they have special, instead of just rebar, there's special cables and wires that go in the tank that stabilize it. So whatever direction an earthquake might hit us from, it'll be stable. And inherently, the design of the tank is stable because it's partially buried. As you can see from the illustration, about 15 feet of the tank will be above grade, but the majority of it and the majority of the weight will be below grade, which just aids in seismic stability.
It's quite a lot of dirt that essentially left the hole.
Yep.
And first of all, I wanted to thank the neighbors here for their patience, because that meant a lot of traffic getting the dirt down so far, and we'll still have to bring the concrete up. So there's definitely an impact, and we really have to thank everyone who lives on this road for their patience with us. Also wanted to thank in this context the Western Water, who's been doing a very good job communicating with everyone and is really watching out that the impact is as low as possible. But again, maybe you can lose some words about the environmental constraints that we have to face, and we're happy to comply with, of course, and how we're actually managing the dirt.
Okay, well, some of the environmental concerns that Clemens is talking about was trees. We had to coordinate very closely with the county as far as what trees that we could take out, what trees we could not, and we have a permit for that. We also had an environmentally sensitive animal, the San Francisco dusky-footed wood rat. He's a cute little rat about this big, but very ingenious. He builds condominiums out of sticks and twigs, and fascinating little animal. But we had to watch out that we didn't get in his habitat, and to do so, a lot of the area that you see beyond the trees back there was designated for stockpile area for the surplus material that we're taking out. Some of it needs to remain on site because we'll use it for backfill. But what we had to do is get environmental clearance, make sure that there was no animals up there, and make sure that we weren't adversely affecting any of the trees. The area, as you can see, is chock full of material, and we really have no more room up there. And the district has been gracious enough to allow Western Water to temporarily store some material down behind the main office, and so got it all covered. It's all secured down there. And if you know anybody, anywhere, who needs dirt, we have lots of it, and it's good stuff.
It's clean.
Soil farm?
It's very clean. The soil farm, what's Rice Trucking? They have a soil farm. They're really interested in it, and they've been helping out, taking some, but
And Andrini's.
yeah, Andrini might need some. You know.
And maybe Linkso over in Rowood City.
Where?
Linkso, L-Y-N-G-S-O.
Above, you know, in dire need of some repair. I don't know if we can displace all the material that we need to get rid of, but any bit would help, you know.
Right.
Even a thumb, you know, a little bucket, 5-gallon buckets, whatever, take it.
Right, and I think it's also worth mentioning that we are working actively with a biologist who spends a lot of time up here to make sure that we are not encroaching in the habitat of the wood rat or impacting raptors, etc.
Exactly, exactly. He's up here monitoring on a weekly basis.
He knows when I'm going.
You've already contacted them. They're locals. Yeah.
exactly. You end up on 92, you see that there's higher you came up. It's the outlet pipe to the tank. The fill line is up above. And that flange, when the tank is completed, will be about 9 inches off the bottom of the tank and about 5.5 feet in from the inside wall. 5.5 feet, Danny? 5.5 feet in from the inside wall. So, I got a bad foot, I can't jump over there, but probably just around the edge of this concrete will be the outside of the wall. All this will be buried, and about right here will be the base of the slab. And at that point, we'll build the walls, reinforce them, cast them, and there'll be, when we're done, about 9 feet between this wall you see here and the new wall of the permanent
Oh,
tank.
9 feet.
9 feet. They needed, the tank manufacturer requested 9 feet so he could get his machine to work and do the stressing and forming and post-tensioning.
And so then it will be filled with a previous soil, like gravel or sand mixture, so that it drains then?
The exterior of the wall will have a geosynthetic membrane on it
Right.
to prevent any water to migrate down to the bottom into a peripheral drain system, which you see is being constructed now.
Okay.
There'll also be an upper surface drainage system that will direct water away from the tank.
Right.
They say in civil engineering the 3 most important aspects of any design is drainage, drainage, and drainage. So we take it pretty seriously here. You know, there's so many problems that can happen if you improperly drain. Flotation, buoyancy, a whole host of problems. So.
And maybe we should also go a little bit into why we're choosing this design. Essentially, it has to do with height restrictions that we cannot build over how many feet it is over the ridge?
Is it 15?
18 feet above the existing ridge line. So to be able to fit a 500,000 gallon tank on the fairly narrow footprint, we have to go down and then essentially backfill. And you couldn't backfill with a regular steel tank. You probably see 80% of the tanks in California are steel tanks. And so we had to go with the concrete tank design because it needs to be partially backfilled. So we will see the tank actually go up 18 feet, I think.
Projecting up, it's about 15 feet above
15
the
feet.
finished grade. The finished grade is approximately the top of the wall right now. And the tank will be projecting above that about 15 feet. But as you can see, the majority of it, the bulk of the water, the bulk of the tank will be below grade and not exposed to the environment. So just improves its longevity, seismic stability. There's so many benefits. But the biggest one, as Clemens is saying, is that we needed to keep this thing out of sight as much as possible.
But being a concrete tank, it's useful like
A pool cleaner that goes around inside it?
That's a really good idea. I'm going to invent that. No, the tank will operate similar to any of the other tanks in the system, where it through mixing, through the water coming in and going out, we hope not to have any sediment settling to the bottom. But a lot of times, the periodic maintenance that the district does to the tanks is getting in, having a diver in there, and they can actually vacuum out any sediment or built up material.
And Tim, in the past, we actually stayed away in the recent years from divers. Divers have to be, of course, disinfected going in. We have been using robots to inspect tanks in the past in the district here. So.
Wow. Gosh, it's already been invented, yeah?
I know, but the automatic pool cleaner, I'm on that one. Once I get the patent, I'll let you know.
Is this going to be dealing solely with well water, or does this interact with the creek, spring water here we have?
It is primarily well water. It depends on how much demand is in the system. Essentially, these two tanks, the existing one and this one, are floating the entire system, or majority of the system. And so if there is, so the existing tank will be the clear well for the treatment plant. It will see the majority of the surface water. This one will see majority of the groundwater, but depending on demand, we'll see an interaction between the two, also between the entire distribution system. So we might produce more water in the lower sections, more groundwater that essentially gets pushed up during the night and fills the tanks. So we see in general in Montara the majority being groundwater. So around, what is it right now? Around 10% is probably surface water and 90% groundwater.
Would this well by itself require treatment, the water from this well?
It doesn't require treatment, but the state has recently changed the rules for all wells and now requires at minimum chlorination. So the water is very good. It's extremely excellent. In fact, there's actually a vodka that you can buy that utilizes the water directly from this well. Someone is utilizing this water to produce vodka because it's so good. It's really good quality water. We had others that brew a batch of beer off it, but it's nothing commercial. The vodka is a commercial undertaking. So yeah, did I answer the question? Essentially, water quality was good.
Clemens, how does the water get uphill in the night?
And that is essentially the tank. So it's being pushed up towards the tank.
What? I mean,
The pressure through the pump. The pressure through the pump in the well directly.
And the outside of the wall is still at 9 feet. Again, we need 9 feet for the machine to make its way around. Again, the soil nails have been tested to several thousand pounds, and those the anchors you see with the yellow marks or orange marks on them, those are the ones that were tested. I'm going to take a ride down the hill with
That sounds
just
good.
about December.
This drain, does it get pumped out or does it seep into the ground?
No, it's a perforated drain, and its high point is about right here, and it's pitched to that manhole right over there,
And then where's it go?
and then that manhole has a pump. Pump it up to daylight.
Rain harvesting is
Again, this is put in to assure us against buoyancy and flotation. It really doesn't take much. Yeah, it'll act like a ship. When the tide goes up, it'll raise it. Due west. There won't be much.
Yeah, the drainage from like when it rains and stuff like that.
So we're standing. So here's the access road going around us. The well is way over here.
Right.
There. Here's our pump station. And daylighting discharging into this manhole. And this manhole is one pipe that goes out into the environment.
Next time we're going to have a concert up here.
Of the walls with GPS marks and benchmarks all around the tank, monitoring them on a weekly basis, just to make sure nothing's moving. So, and nothing's moved an inch.
And who's the other contractor that's contracted out to do that?
Hillside Drilling was their name, and they did a great job. They were very quick, very clean.
California.
Are they in Richmond? Okay. That allows, if we have water coming in through veins and different strata in the soil, it'll hit that membrane, go down, and leak out through these pipes, instead of putting hydrostatic pressure on the walls, which could cause a failure. And so the idea again is just drainage, drainage, drainage. Get rid of it. Get it out of your way. Get it away from the structure. The most important thing.
And then they'll tie into this trap.
No, eventually these will be abandoned because we will backfill here and hydrostatic pressure won't be an issue for us. Sprayed concrete and wire mesh reinforcement.
Only 6 inches.
But that's real high PSI concrete, right?
It's the shotcrete is not that high. It's maybe 4,000 psi,
Yeah.
but it's not so much the compressive strength of the concrete, but the tensile strength of these anchors that really provide the benefit and the strength in the wall.
Storage.
Storage capacity?
Yeah.
Well, I know we have 200,000 at Schoolhouse, and we have 500,000 here.
There's another 500,000 sitting here.
And and then the other half million
There's
here.
another 100,000.
Over at Portrol, right?
So it's a half and half a million.
So the idea was that the district can sustain after a major event for 2 days with no sources working.
Hopefully that won't ever happen.
Right.
And it's 9 foot. No, 12.
Eventually be buried. We'll use this for vehicular traffic, for building the tank, and for the exiting pipe. But eventually, when we backfill, this road will be backfilled as well, and the tops of the walls cut off, and the restoration of the surface will include new vegetation, plantings, pavement, fencing, and finishing touches. The material, moving the material, stockpiling it somewhere, trying to get rid of it, and we need to maintain some of it on site for backfilling, but the big challenge so far has been handling the material, trucking it. We can only do it in small quantities in small trucks, and we need to be conscientious of the environment and the residents who are tolerating the truck traffic.
Pretty proud of the job so far?
Oh, very proud, very proud. We'd like to showcase it and show it off.
Thank you.
Okay.
Get hot peppers.
What time? 6:45.